Hi, everyone. I'm Antonio. I'm currently the Chief Operating Officer at Polyhedra Network. It's so good to see everyone here today. Thanks for Alto Iterative for having me today for such a wonderful event. And it's so great to see a lot of familiar faces. Have Merlin, Babylon, Yala Finance. A lot of our partners are here today. So today I'm going to talk a bit about Polyhedra Network and what we are doing for Bitcoin ecosystem. But first, let me give a brief introduction about what we do in general. So Polyhedra Network, what we built, the flagship product is the ZK Bridge. We initially came from a research background where we have a lot of ZK researchers in our team. So first thing we thought of would be secure and efficient cross-chain interoperability infrastructure. That's what we call ZK Bridge. And nowadays, ZK Bridge has over 20 million transactions through the bridge, and we have proved over 40 million zero-knowledge proofs across different blockchain networks. Besides ZK Bridge, we also provide infrastructure algorithm layer for different companies, projects, and our partners. We are the inventor of the world's fastest zero-knowledge proof system expander, and our founding members are the author of a lot of great algorithms, including Orion, Virgo, Merlin, Gemini, dVirgo, you name it. Then with that all, we are also providing a lot of developer tools, easy to use, Web 2 and Web 3 friendly, so that developers can easily build on us with our great infrastructure. So here's what we provide. On the underlying layer, we have the protocols. Those are the underlying algorithms we utilize to provide the most efficient and secure solution for zero-knowledge proof industry. Then on the foundation layer, we have our compilers, distributed ZKP algorithms. We also have built Proof Cloud, which enables non-ZK developers actually get a taste of how ZK projects are built and deploy your own ZK prover and verifier using our integration tools. And on the application layer, well, we call it application, but it's still generally known as infrastructure. So we have ZK Bridge, we have ZK Consensus Client, we have ZK Oracle, and of course, we have zero-knowledge proof for Bitcoin ecosystem. Well, so that's why we're able to build it, why we are the only ZK project that is able to provide production-level interoperability protocol and production-level computing power, is that we have a very advanced algorithm system we call Expander, which is proven to be the world's fastest zero-knowledge proof system. So within Expander, we have a lot of tools all integrated into Proof Cloud for developer to utilize. So that's one of our collaborations. So the pain point we are seeing nowadays in Web3 industry is that we need new users. And all new users come from Web 2, actually. So one solution we're providing is that we are now officially a partner with Google Cloud. We also have our infrastructure in Google Marketplace, where developers are able to directly use Google's interface to build Web 3 products. In a different words, developers from Web 2 will be able to engage in Web 3 now with advanced zero-knowledge proof products and other satellite products we're having. So with all those great infrastructure, we need applications. So one of the things we provide to users is the ZK Bridge. As I mentioned, it has over 20 million transactions across it, connecting to over 30 different ecosystems, including Bitcoin, including Ethereum, including other ecosystems. Now, ZK Bridge is the only production-level bridge that is trustless. So the reason why we built it, and also the reason why we're also bringing ZK Bridge to Bitcoin ecosystem, is that the only concern, the most significant concern for bridging solution, especially when it comes to Bitcoin, will be security and verifiability. So we want everything to be verifiable instead of being multi-party computing, instead of being signed by individuals or multiple nodes. So internally, we have a saying, in math, we trust. So everything through ZK Bridge is proved by our ZK technology, including all Bitcoin transactions, including all interoperability protocols across all different blockchains. We do not have nodes. We don't have multi-party computing. We don't have people who need to sign for transactions. Instead, we generate ZK proofs for all the transactions that's happening on-chain. And all those proofs, you can verify them. The smart contracts on-chain are open source. The proofs are public, so everything you see can be verifiable. And only through an open, verifiable infrastructure comes the most secure and most efficient cross-chain solution. So this is trusted by and proven by the industry. And we are further expanding ZK Bridge to multiple ecosystems, including Bitcoin and potentially even Web2 sectors, because we built ZK Bridge for a general interoperability solution where it is capable of connecting Ethereum, Bitcoin, even your Web2 database. And also for developers from Web2, we also offer ZK Bridge to help you connect to Web3. We also help traditional finances, banks, and other institutions to get on interoperability solution with this. And now, Bitcoin. So Bitcoin is a slightly different topic, because as we know, Bitcoin does not have smart contracts. Now the problem is, since we want to verify anything, we want to verify everything, how can we verify it with ZK proofs while Bitcoin has no smart contracts? So on the morning panel, we talked about BitVM, but admittedly, there is still some time needed for developing an application-ready Bitcoin. So some solutions we are having right now, first is what we call Bitcoin AVS. That's also working with EigenLayer together. We call it Trust Minimized Bridge from Ethereum to Bitcoin. So the idea is simple. If we cannot verify things on Bitcoin, we can verify it on Ethereum and have them connected with ZK Bridge. Simply speaking, what we can do is we call it Bitcoin messaging protocol. So every transaction happen on Bitcoin, we will be able to prove it and verify it on Ethereum. Now the question becomes, with this infrastructure, how we are able to build an interoperability protocol. Because one bottleneck for a lot of Bitcoin projects is that Bitcoin is expensive. And there aren't that consumer on Bitcoin playing, like Bitcoin do not have a DeFi, Bitcoin do not have GameFi. So the question is, how do we connect Bitcoin to a more general Web3 ecosystem, or even more, how do we connect Bitcoin to the world? And this is the interoperability protocol we're having. Specifically, what's happening here is that we call it trust minimized because we need trustee to deposit on Ethereum first. We are working with a lot of staking protocol, including EigenLayer, including Renzo, including Swell, to have their collateral deployed on Ethereum or any EVM chain or any chain that has a smart contract. Then when the cross-chain transaction happens, we need to verify if the transaction indeed happens on Bitcoin. If the Bitcoin transaction is valid, then we generate a ZK proof of that transaction. Then we verify the transaction on Ethereum, so that, or any other EVM chain, so that Ethereum will be able to know what's going on Bitcoin. So if anything goes wrong, there is collateral on Ethereum, and that collateral will be slashed. So in this way, we are able to come to what we call trust minimized bridge for Bitcoin, where users submit a request for cross-chain first, then we have the validators execute the transaction on Bitcoin. Then we verify the execution of the transaction by using ZK proof and our ZK bridge technology. Then at last, if anything goes wrong, if the transaction on Bitcoin did not happen while the user claim it happens, we will be able to slash the one who actually validates this transaction. So that is Bitcoin trust minimized protocol. But why do not we go one step further? How about we have a fully trustless cross-chain protocol that requires no trust assumption? You don't need to trust anyone. You don't need to listen to any institution. You don't listen to node operators. But everything is under your control, under users' control. So that's what we call a fully trustless cross-chain Bitcoin token swap based on ZK Bridge. Pros and cons. Pros of this solution is that we are able to make this entire system completely trustless so that you don't need to trust anyone by doing it. There is 100% guarantee during the cross-chain process your asset will not get stolen. Your asset, you will not lose control of your asset. The con is that with the trust minimized bridge, you can actually do message bridge. So you can verify the data on Bitcoin. You can verify any arbitrary message from Bitcoin to other ecosystem. However, with the trustless cross-chain solution, right now what we do would be token swap. So we only support Bitcoin with wrapped Bitcoin, and that's the only constraint. Now, how are we able to do it? So it's the idea is simple. There will be a maker. It could be anyone. It could be a consumer. It could be an institution. So there will be a maker who is willing to provide this cross-chain service, who's willing to provide liquidity to the system. Then what the maker does is the maker deposits their collateral on Ethereum. Then this collateral goes to a smart contract that does not go to the user directly. The maker still deposits the collateral on a third-party, verifiable open source smart contract. Then for the next step, the user will also need to send the cross-chain asset from the user's wallet to that smart contract. At this point, all assets are securely stored on that smart contract. No one has access to it. No one can get it out. Then next step, since the asset is in that Ethereum smart contract already, and what the user is requesting is that the user would want the tokens on Bitcoin. The user will want Bitcoin token. So the maker will have to send the token from his own address on Bitcoin to the user's address. So in that case, the user indeed gets his token. Then for the next step, how does the maker get the user's payments? That's the power of ZK Bridge. Since the thing we can do is that we can verify every transaction on Bitcoin. And the last step, the maker has sent a transaction over, so that transaction is valid on Bitcoin. And as long as that is a valid transaction, we can use our ZK proof system to prove that the transaction indeed happened. Then with this ZK proof, we can actually submit it to the smart contract on Ethereum network that's holding the token. Then on that Ethereum smart contract, the smart contract will automatically accept the proof from Bitcoin. And after it accepts the proof and verify the transaction, so the Ethereum side will understand what just happened on Bitcoin. Then the maker will be able to get the money back. So how do we keep this system secure? Why am I saying this is a trustless asset bridge? It's because something could happen first. If the user does not pay money to the maker, then before that, the smart contract on Ethereum will know if the payment is pre-approved, its payment is deposited into that smart contract. So using smart contract, we are able to program on Ethereum to make sure those steps happens. Then the second step on any of interoperability protocol is that if the maker, the liquidity provider, tricks the user, and at the end, the liquidity provider does not give the user the real liquidity, what would happen? So in that case, the transaction on Bitcoin will not take place. Then we will not be able to generate a valid ZK proof for that transaction, so that the smart contract on Ethereum will not be able to receive a valid proof of the completion of the transaction on Bitcoin. Then the smart contract will not be able to give the tokens back to the maker. Then the third question is, as a maker, if I were a maker, how do I guarantee that I will get my money in the end, that will get my liquidity? So this is also done through zero-knowledge proofs plus smart contract. Since smart contracts on Ethereum, it's open source, it's public, everyone can check it, and codes cannot be altered. So as a maker, I can check the smart contracts to verify that as long as I have the proof of the transaction happening on Bitcoin, then I will be able to get my money back out of that smart contracts as long as I submit a valid proof to the liquidity pool. So through this infrastructure, we are able to make a trustless cross-chain Bitcoin token swap through ZK Bridge. And together with this token swap and also with the trust-minimized asset bridge, we are now providing services to a lot of our partners, including like BitLayer, including here Merlin, talking to Babylon, and we're also providing to more and more Bitcoin layer 2s and also Bitcoin ecosystem projects. Because we use zero-knowledge proof protocol to build this bridge, it can not only support an asset crossing, it can actually verify anything happened on Bitcoin. So this opens up possibilities for not only Bitcoin layer 2s, but for Bitcoin ecosystem projects, including ordinals, including runes, including, in the future, Bitcoin 5. So here we are. We provide this interoperability solutions through our fully trustless zero-knowledge proof protocol. And we are keep innovating, we are keep advancing our protocol, making our ZK protocol and also ZK interoperability structure the most secure and the most efficient, tailored for Bitcoin developers. Thank you.